Now let's look at the problem writing the rate law implied by a simple mechanism. This one I'm suspecting is going to be tricky. I think that this one is going to be similar to the last problem on the worksheet for 19.7. So first thing we have to do is write a balanced chemical equation for the overall reaction, and that is not going to be the hard part. We have, in step number 1, we have NO, we have Cl2 as reactants. In step number 2, we have NoCl2 and another NO. And don't forget, you need to include states when you're putting this into ALEKS. And then for our products, we have NoCl2 for step 1, and we have 2NoCl for step 2. And then we need to get rid of our intermediates. So NoCl2 is our intermediate, and we want to get rid of it. Now for the next part, it says write the rate law. The rate law is going to be based on the slow step. So it says up here, the first step is faster than the second. So that means that step number 2 is our slow step, and that is the step that we'll use to determine the rate law. So the rate law based on the slow step is going to be K2, the rate constant for the slow step, times NoCl2 times NO. However, this form right here, not allowed because NoCl2 is an intermediate, and we're not allowed to have intermediates in our rate law. So how do we go about getting rid of an intermediate? To get rid of an intermediate, we're going to go to our other elementary step, not the one that we're using. We're going to go to the other one, and we're going to use the principle that the rate of that reaction forward is equal to the rate of that reaction backwards. The rate law for the forward reaction is going to be K1 NoCl2, the reactants in the forward direction, equal to the rate law for the back reaction, K minus 1 NoCl2, the reactants for the back reaction. What we need to do is use this equation right here to come up with an expression for our intermediate, NoCl2. So you guys can see what we need to do. We need to divide both sides by K minus 1, and that allows us to come up with an expression for NoCl2. Before we get all excited and think that we've done it, we do need to ask ourselves, do we have any intermediates here? What about NO and what about Cl2? If we look at our overall reaction, both of those are reactants, so that means no intermediates, so that means this is going to work. This will be good, so what we're going to do is take all of this right here and substitute it into the rate law for NO2. So that's going to give us rate equals K2, K1, NO, Cl2, K negative 1, NO again. What I got here is this K1 NoCl2. That was the term that I came up with to substitute for NoCl2. Let's use a different color from the original rate law, K2, and also NO right there. Now, when we put this together to come up with the actual rate law for the reaction, in order to keep things simple, notice that we're just using the single letter K. So that means down here, we need to define what K actually means. K is K2, K1 over K minus 1. So for this step down here, we're taking all of the Ks, and we're just looking at what do they look like in this rate law. Copying that in, substituting that, calling that K. And up here we have NO, and we have 2 of those, so that means it's going to be NO squared times Cl2.